Hello and welcome to our first of undoubtedly many lecture videos for Math 254 during the spring of 2020. Now spring of course means summer as well, but we're going to be enjoying the last part of spring and the beginning of summer together. Actually most of summer together. So we're going to start off in Chapter 1, and Chapter 1 starts off with just a page of some quick refreshers and kind of vocabulary ideas that we need to keep in mind as we're moving forward. So the first one is the idea of a differential equation. Now, you may think that you haven't seen differential equations before because you haven't taken the class, but you actually have, because a differential equation is really just an equation involving one or more derivatives. Of some stated variables. And we're going to talk more about what that means in a second. But let me give you an example of a differential equation that you've run into before. So something as simple as y prime equals 2. And if I said, hey, what kind of function y would solve that? You can probably in your head come up with the method to solve that, which is you're just going to integrate both sides. Of course, with respect to what, it's not entirely clear because y prime could be dy dx, it could be dy dt, it could be dy dp, or any other variable. We don't know. But let me give you another example that may look a little bit more daunting. Y double prime plus y prime plus 2 equals e to the x. And you might look at that and think, wait, how am I going to solve that? Well, we'll get there eventually in the class, but what this is really saying is take the second derivative of some function, add it to the first derivative of that function, add the number 2, and you get e to the x. So whatever that function is, whatever y is, its second derivative and first derivative, when combined in this particular way, add up to e to the x. So it doesn't have to be anything that exciting. It could just be something like 2 times y prime plus 3x squared equals sine x. That's another example of a differential equation because it involves the derivative y prime, but it's got other stuff going on too. So we're going to restrict our attention, at least at first, to first order differential equations. First order having nothing to do with Kylo-Ren. First order just involves first derivatives. So when you're thinking about an equation like the top one here, that is a first order differential equation. This one is not because it's got a second derivative there. And you're probably not at all going to be shocked to find out that that is technically a second order differential equation because it's got a second derivative in it. So just vocabulary wise, knowing those two words is important. You'll notice the next bullet says derivative as rate of change. And we talked a little bit about this yesterday in class. The idea that you can think of the derivative as a couple of different things. The first thing that we learn it as is really it's the slope, right? The rate of change. So if you're thinking about y prime as dy dx, or maybe it's y prime as dy dt, whichever way, both of these are telling us something about what's going on with the derivative. It's telling us that the slope is a rate of change of y with respect to some other variable. And so down here, in this case, we have an x or a t, and both of these are clearly the independent variable. And you can tell that they're the independent variable because they're in the bottom of the derivative, or the differentiation argument there. So dy dt, clearly it's in the bottom, right? And you can also tell that the y and the t, or excuse me, the y and the y over here, are the dependent variable. And you can tell they're the dependent variable because they're in the top. So we take the derivative of some dependent thing with respect to some independent thing. And so a derivative as a function is the next thing that we're going to talk about. The rate of change of some variable with respect to something else is one way, but the derivative as a function is another way that we can think about it. And the way we write it here, you can tell the first thing inside the function notation. And you may not have seen it written like this before, depending on where you've taken calculus. But the first one is always the independent. And then the second, and if there's more, the third, the fourth, however many there are, those are the dependent variables. Right? And that notation, that function notation, is important because remember, the derivative is itself a function. And so up here, this is a function. Y prime is a function. And if we imagine it's a function of x, you could say y prime is a function of x. And it is fundamentally different than y of x. And we know how to get to y from y prime. We just integrate y prime. But the derivative is a function. And so let me give you some examples of derivative as a function. And in this case, this first one here, you can tell that not only is the derivative a function of x, the independent variable, but it's also a function of the dependent variable. So in this case, this is a function of x and y. As a matter of fact, all of these are functions of x and y. And you can tell that they're functions of x comma y because that y prime is telling us that the dependent variable must be the y. But what's interesting about all three of these, you might look at them and think, oh boy, I think I might be able to solve some of these. And it turns out that this first one is literally super easy to solve. The second one on the list, this guy right here, it's a little bit harder to solve. And so we're going to probably in the next section learn how to solve this type of differential equation. And then later on in this chapter, we're going to learn how to solve this type of differential equation. And then if you take a look at this guy right here, you might think, oh, well, if that second one is harder to solve, this one must be maybe a little bit harder to solve. It turns out this one is actually impossible to solve. And I mean impossible to solve analytically. And I'm going to toss that around a couple of different ways. Solving something analytically means using the rules of algebra and calculus to manipulate things, right? Just like you knew how to solve the integral or integrate to get the solution for the equation up there. Turns out this one, there are no tricks. There are no algebra or calculus tricks to be able to solve it. And for many of you, this is the first time you may have run into this in your math experience. An equation that can't be solved using analytic means. There are other ways to solve it, just not the way that we're used to thinking, the algebra plug and chug kind of method. So the next concept that we run into on this page is proportionality. And this is one of those phrases that you probably pick up in science and math and a lot of other subjects. But basically it runs like this. If A is proportional to B, this phrase right here, A is proportional to B, that can be rewritten as A, and then we use a little kind of fish symbol. Sometimes there's little legs on the end of it, but it's A proportional to B. And what that means is that if you were to relate these two in an equation form, you would say A is equal to some constant times B. And this guy right here, this is referred to as the constant of proportionality. Another way some people might write the proportionality equation is to say that if you take A and you divide it by B, you always get the same number. But you can see those are really the same equation. Those mean the same thing. Proportionality is a statement of relationship between two quantities. So your grade is proportional to the amount of time you study, right? That makes sense. So the very last thing on this page, and I'll probably cut the video off after this, is just a little reminder that we have some tools for being able to solve some things and answer some questions that we may have learned in pre-calculus times. So let's say we're given an equation like y equals x plus 3 over 1 minus x. And it asks for what values of x is y 0, positive, or negative. And so you might look at this and go, okay, so for what values of x is y equal to 0? Well, the only way this equation could equal 0, since the right-hand side is a fraction, is if the top is equal to 0. So you might look at it and say, that's where the numerator is 0. So that means you'd solve for x. x plus 3 equals 0, and you'd find out that x equals negative 3. That is the x value for which y is equal to 0. It's the only one. It's the only way it can work is if the top is equal to 0, the numerator. How about positive or negative? Well, that's a little bit different. But the good news is that if we know that x equals negative 3 is where it's exactly equal to 0, we can look on either side. And so in order to make sense of where is it positive or where is it negative, we're going to set up and use intervals. And if you remember this from your Calc 1 or maybe pre-calc days, intervals, there we go. You might say, okay, I'd look on either side of where x is equal to negative 3. And of course, if you're playing the at-home game, you probably might recognize that this right here could also be a problem, because where the denominator equals 0 is another concern. In other words, you can't let x, in this case, equal 1. Because if x equals 1, then it causes major problems. So your intervals would probably look something like, I'm going to look at everything from negative infinity all the way up to negative 3. And then I'm going to look at everything from negative 3 all the way to 1. And then, and I'm going to look for everything from 1 to infinity. And if this looks vaguely familiar to you, it's because you've seen interval testing before in a couple of different contexts. And so you would test within these intervals. To find where y is greater than 0 or y is less than 0. Right? Because you know it can't be 0 anywhere else other than negative 3. And we've excluded x equals 1 as a possible location to pay attention to. So that gets us to the end of just this first page. And remember, this first page is really just kind of a grab bag of ideas and concepts that are going to come in handy throughout the course and definitely within Chapter 1. So I'm going to stop the video here, and you can continue on to the next video.